Right now, somewhere in the universe, a black hole with the mass of 4 million suns is sitting quietly at the center of our galaxy. It's not hunting, it's not moving toward us, it's just waiting. But what if it wasn't? What if, for just one video, the rules bent? What if Earth left its orbit, drifted out of the Milky Way's spiral arms, and began falling? Not toward a star, not toward a planet, toward nothing.
Here's the twist nobody tells you. The bigger the black hole, the less violent your death. Let's find out exactly how it happens. Minute by minute, second by second, until there are no seconds left.
First, let's be fair to Earth. Space is big, and black holes, even supermassive ones, are small targets. So let's assume the impossible has already happened. Something has knocked Earth out of a stable orbit, and it's now in a slow, silent free fall towards Sagittarius A, the supermassive black hole at our galaxy's core. For most of the trip, almost nothing happens. This isn't like a movie. There's no swirling vortex yanking us in from a million miles away. For years, maybe centuries, Earth just drifts. Colder, darker. The sun, our sun, shrinks to a point of light and then disappears behind the glow of the black hole's accretion disk. People on Earth wouldn't know the exact moment of no return. There isn't a line in space that says turn back now, but there is a real one, invisible, mathematical, and absolute. It's called the event horizon. Cross it, and not even light can climb back out. Not radio signals, not a scream, not physics itself.
Here's where most people expect the horror to start. Ripped apart, stretched like taffy, reduced to a stream of atoms before you even reach the edge. That's real. It's called spaghettification, and it does happen at black holes. But, plot twist, that's the fate of falling into a small black hole, a stellar mass one, maybe 10 times the mass of our sun. Those are compact and vicious. Their gravity changes so drastically over just a few feet that your head and your feet would feel wildly different forces. That's what tears you apart. A supermassive black hole is different. And this is the part almost nobody explains right. The event horizon of Sagittarius A star is roughly 17 times wider than the sun. Because it's so enormous, the change in gravity from Earth's near side to its far side, right at the horizon, is almost nothing. The tidal forces are gentle enough that Earth could cross the event horizon completely intact. No stretching, no tearing, no warning sign at all. You would cross the point of no return and feel nothing.
Let's sit with that for a second, because it's the most unsettling fact in this entire video. From Earth's perspective, crossing the event horizon isn't an event at all. The sky would look strange. The entire visible universe would appear to compress into a shrinking, brightening circle directly overhead, an effect called relativistic aberration. But there's no flash, no barrier, no resistance. Meanwhile, somewhere far away, a hypothetical observer watching through a telescope would see something completely different. To them, Earth never actually finishes falling in. Time near the horizon appears to slow down from the outside, more and more, until Earth seems to freeze, dim, and fade, a ghost image stuck at the edge forever. Two versions of the same event, one where Earth calmly continues its fall, one where Earth appears to freeze in time eternally. Both are true, depending on where you're standing. That's not science fiction. That's just what Einstein's relativity actually predicts. But inside that horizon, the calm doesn't last. Once you're inside the event horizon, something strange happens to the geometry of space itself. The direction toward the singularity stops being a direction you could choose to avoid. It becomes the only direction time moves in. Falling inward isn't optional anymore. It's not even really falling. It's just the future. And now, finally, the tidal forces start to matter. As Earth gets closer to the singularity, the gravitational gradient sharpens. The side of Earth facing the center gets pulled harder than the side facing away. Slowly, then catastrophically, Earth begins to stretch. The oceans go first, torn into vapor and streaming ahead of the planet like a comet's tail. Then the crust, then the mantle. Earth stops being a sphere and becomes a thread, a spaghettified filament of what used to be a planet, 1 atom wide, stretched across thousands of kilometers. This is the spaghettification everyone expected 2 minutes ago. It just took a lot longer to arrive than the movies promised.
And then, the singularity. Here's where honesty matters more than spectacle. Nobody knows what actually happens at a singularity. General relativity predicts a point of infinite density, where the equations simply stop working. Most physicists don't think that's a literal truth about the universe. They think it's a sign that relativity breaks down, and that only a theory combining gravity with quantum mechanics could tell us what's really there. Some theories suggest the matter is simply crushed into something we have no name for. Others propose it never truly ends at all, that what looks like a singularity from the outside connects to something else entirely on the other side. Nobody can test this. Nothing that crosses an event horizon can report back. Whatever Earth becomes at that point, it's no longer a planet. It's not even matter as we understand it. It's information. The raw data of every atom that ever made up our home added to the mass of the black hole itself. And Sagittarius A star would be very slightly 4,000,001 Earths heavier than it was before. None of this is going to happen. Earth is nowhere near Sagittarius A star. We're about 26,000 light years away, safely orbiting a completely ordinary star. And we're going to stay that way for a very, very long time. But the thought experiment tells us something real. The universe's most feared objects don't always behave the way we imagine. Sometimes the gentle giant is the one that kills you without you ever feeling the moment it happened. And sometimes the true horror isn't the violence, it's how quiet the end of everything can be. If you want to know what happens if the sun disappeared instead, or what it would actually look like to stand on a neutron star, let me know in the comments and subscribe for the next What If.